So this is the first circuit that you're going to build in this lab. It's a very simple circuit. You have a variable voltage source and an 820 ohm resistor. You're going to be measuring the current through the resistor and the voltage across it. If you are doing this lab in person, measure the value of R1 and record its value in here. If you are doing it online, then you can simply just put this to 820 ohms. Then you're going to vary the power supply voltage from 0 to 20 volts, just like in here, and record the voltage across the resistor and the current going through it. So this is going to be the voltage, and this is the current. If you are doing this lab in person, you might notice that the voltage across the resistor is a little bit lower than the applied voltage. And this is because the ammeter is not ideal. An ideal ammeter will have zero resistance and will not cause a voltage drop. So if the current was flowing through it and it has zero resistance, then according to Ohm's law, V equals I times R, the voltage across the ammeter is going to be zero. But in real life, ammeters have a little resistance, so you will notice a little drop in the voltage. So if you are doing this online, you're not going to notice this voltage drop, and this is because the simulator does not very much simulate a real one. Now after that, you're gonna plot I versus V. So you collected V and I, you're gonna plot I versus V. So I is on the y-axis and V is on the x-axis. You will find the trend line and then you will find the slope. Now you will find that the IV curve of the resistor is just a line as expected. And also when you make the plot, please move it here. The plot will not be graded, only the data is graded, but you still need to create the plot to do your calculations. So after you do the plot and find the equation of the line, you will find the slope and put it here. The slope will have units of 1 divided by ohms. This is because we have I versus V. Find the reciprocal of the slope and you will have the value of R in here. And then you will calculate the percent error between the measured one and the one that you found from the graph and enter that percent error in here. Now if it comes out to be 20%, you can just simply put 0.2 like this. If it comes out to be 5%, 0.05, and so on. Now, if you are doing this in person, you will definitely get something here for the percent error. If you are doing it online, then you could probably get 0% error. And this is because the Tinkercad does not simulate any measurement errors. So each measurement device, like an ammeter or a voltmeter, will have a certain error in the measurement in real life. So there will be meter bias and thermal noise, and that will affect the accuracy of the measurement. But the simulator does not simulate that.